Welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 8th graders out there, though all children are welcome to tune in. This lesson is the second in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. Today, we will be learning about expressions and equations and reviewing writing equations using symbols. Before we get started, to participate fully in our lesson today, you will need the following: paper and a writing utensil or another note-taking device. No calculator will be needed today. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education website at www.tn.gov/education. You can still tune into today's lesson if you haven't seen any of our other previous lessons, but it might be more fun if you first go back and watch our other lessons, since we'll be talking about those things we've learned. Okay, let's begin. Today we are going to be working on linear and nonlinear expressions. You will know the properties of linear and nonlinear expressions in X, and you will transcribe and identify expressions as linear or nonlinear. Let's get started with some vocabulary and key points for today. A symbolic statement in X with an equal sign is called an equation in X. The equal sign divides the equation into two parts, the left side and the right side. The two sides are called expressions. For the sake of simplicity, we will only discuss expressions in X, but we know that we can write expressions in any symbol or variable. Linear expressions in X are special types of expressions. Linear expressions are expressions that are sums of constants and products of a constant in X raised to a power of 0, which simplifies to a value of 1 or a power of 1. Nonlinear expressions are also sums of constants and products of a constant and a power of X. However, nonlinear expressions will have a power of X that is not equal to 1 or 0. In other words, in nonlinear expressions, you're going to see an exponent that is greater than 1. Now, let's take a look at some samples. These expressions that I'm about to show you are examples of linear and nonlinear. And I have color-coded them for you so it's a little bit easier to discern between the two. So here are our examples. Our linear expressions are in red and our nonlinear expressions are in black. It might be a good idea for you to copy this chart down just to have some sort of a reference in your notes for later on. And if you want to color code it as well, please feel free to. Let's take a closer look at two different expressions we have here. 5x plus 3 and 4x squared minus 9. The first one is linear and the second one is nonlinear. What's the biggest difference you see between these two expressions? Take some time to think about that. Did you say that the power of one term in the second expression was not 1 or 0? In other words, because this exponent is greater than 1, it's nonlinear? Then you're correct. The reason we want to be able to distinguish linear expressions from nonlinear expressions is because we will soon be solving linear equations. Nonlinear equations are a set of equations you learn to solve in high school mathematics, though we begin to solve simple nonlinear equations later. We also want to be able to recognize linear equations in order to predict the shapes of their graphs, which is a concept we learn more about in later lessons. Here are some things to remember. You might want to write this down. Terms are any product of an integer, power of x, and a constant, or just a constant. Constants are fixed numbers. When the term is a product of a constant and a power of x, the constant is called a coefficient. Please feel free to pause your screen at this point if I'm going at a pace that's a little bit faster than you would like. Follow along as we work through several examples. We're going to answer the following about each expression. How many terms are in the expression? What are the terms in the expression? Can the expression be simplified? Is the expression linear or nonlinear in x, and why? All right, let's take a look at example 1a. Please feel free to write this in your notes as well. Here's example 1a. So let's go through and answer these following questions. How many terms do you see in this expression? Great, 2. What are the terms? 57 and negative x. It's super important that you take the sign that's in front of the term. Can this expression be simplified? No, there are no like terms to combine. Is the expression linear or nonlinear? Linear because the terms are a constant, 57, and the product of a constant and x, which are -1 and x. So what they're saying is, in other words, we multiplied -1 and x to get negative x. Also, you don't see what you would see with nonlinear expressions, and that is a power raised to anything greater than 1. Let's look at example 1b. So we've got 2x squared plus 9x plus 5. Let's answer our questions here. How many terms do you see? 3. 1, 2, 3. What are the terms? 2x squared, positive 9x, and positive 5. Can this expression be simplified? No, there are no like terms to combine. Is the expression linear or nonlinear? Nonlinear because the term 2x squared has an exponent or a power that is not 1 or 0. Great job. Let's look at example 2. All right, here is example 2. Four plus 3x squared. Again, we're going to continue to answer our questions. How many terms do you see in this expression? 2. What are the terms in this expression? Positive 4 and positive 3x squared. Can this expression be simplified? No, there are no like terms to combine. Is the expression linear or nonlinear? Nonlinear because the exponent or power in the term 3x squared is greater than 1. It's a power other than 1 or 0. Great job. We've got 3 more examples to go. Let's look at example 3. Again, we're going to answer our questions. How many terms do you see in this expression? We see 4 as it is currently. What are the terms? 7x, 9, 6, and 3x. Can this expression be simplified? Yes, we can combine like terms. So we can combine 7x plus 3x to get 10x, and we can combine 9 plus 6 to get 15. Is the expression linear or nonlinear? Linear because there's no term that has a power of x other than 1 or 0. Now let's add a couple more questions to this one. What terms have coefficients? Thinking back to those terms we defined at the beginning of the lesson. What terms have coefficients? So in our original expression, the term 7x has a coefficient of 7, and the term 3x has a coefficient of 3. In our simplified expression, the term 10x has a coefficient of 10. All right, let's take a look at example number 4. So we have 5 plus 9x times 7 plus 2x raised to the 9th power. Okay, we're going to go through our series of questions again. How many terms do you see? You should have answered 3 terms. Remember, terms are separated by a plus or a minus sign, an addition or subtraction sign. So I have 1, I have 2, because this is a multiplication symbol, and I have 3 terms. What are the terms in my expression? 5, 9x times 7, and 2x to the 9th power. Those are my 3 terms. Can this expression be simplified? Yes. This expression, this term, 9x times 7, can be simplified to 63x. We do 9 times 7 to get 63, and then we cannot forget the x. And then we're going to bring down 5 and 2x to the 9th power. Is the expression linear or nonlinear? The expression is nonlinear because the term 2x to the 9th power has a power of x other than 1 or 0. Now, a bonus question here, which terms have coefficients? So in our original expression, the term 9x times 7 has a coefficient right here of 9. And the term 2x to the 9th power has a coefficient here of 2. In our more simplified example, the term 63x has a coefficient of 63. And then again, our term 2x to the 9th power has a coefficient of 2. We've got one more example to go, and this one's going to be a little bit trickier. So here's your example 5. We have 94 plus x plus 4x to the 4th power. Let's see what's a little bit different here. How many terms do you see in this expression? We see 3 terms. What are the terms? (94) x and 4x to the 4th power. Can this be simplified? No, it cannot be simplified. We do not have any other terms we do not have any like terms that we can combine. Now, is this expression linear or nonlinear? This expression is nonlinear because this term 4x to the fourth power has a power of x that is greater than 1 or 0. Now I'm going to change something about this expression, and I want you to think about whether or not this would make this a linear expression or a nonlinear expression. What if I made this power of 4 a negative 4? Would this be linear or nonlinear? So this would still be a nonlinear expression because this is a power other than 1 or 0. Anytime you have an exponent that is other than 1 or 0, your expression or your equation is always going to be nonlinear. Sometimes negative exponents show up in expressions, but that's not going to change our rules about linear and nonlinear expressions. All right, that was a lot of examples. Let's get into some guided practice now. So let's incorporate some of our skills in writing expressions in symbols along with determining if the expression is linear or not linear. Don't forget to define the variable first. I want you to try these on your own. Okay, combining what we did in our first lesson with today. So again, you're going to write me a mathematical statement, and then you're going to tell me whether or not this is linear or nonlinear. I will read these, and then I will give you some time to work on your own. Again, I will probably go at a pace that's a little bit faster for you, so please feel free to pause your video at any time. Number 1, the sum of a number and 4 times the number. The sum of a number and 4 times the number. So I want you to write me a statement with that, and then I want you to tell me if that is linear or nonlinear. All right, number 2, the product of 5 and a number. The product of 5 and a number. Write me that statement and then tell me if that is going to be a linear expression or a nonlinear expression. Okay, number 3, multiply 6 and the reciprocal of the quotient of a number and 7. Multiply 6 and the reciprocal of the quotient of a number and 7. Number 4, twice a number subtracted from 4 times a number added to 15. Twice a number subtracted from 4 times a number added to 15. And then number 5, the square of the sum of 6 and a number. The square of the square of the sum of 6 and a number. So do your best to first write these mathematical statements. Tell me whether or not they are linear or nonlinear. I would encourage you to give yourself a goal. You have 5 problems, so try to get 3 or 4 out of 5. And then I'll put up the answers to this guided practice and you can compare. All right, let's check your work. Again, if at any point I'm going too fast, please feel free to pause your video. So I'm going to put our answers side by side to our practice problems. Okay, so we have the sum meaning what kind of problem am I talking about? An addition problem. So the sum of a number, what would we put there? We would put x, a variable, and 4 times the number. So if we have defined the number as x, then that's what we've got to use in the entire expression. So we have the sum of a number and 4 times the number. So we have x plus 4x. We can simplify this because we have like terms here. So it's simplified to 5x. And that's linear because there's no term that has a power of x greater than 1 or 0. All right, number 2, we had the product of 5 and a number. The product of 5 and a number. What does that term product mean? What kind of problem am I talking about here? A multiplication problem. So the product of 5 and a number would just be 5x. It would be linear because no term has a power of x greater than 1 or 0. Number 3, multiply 6 and the reciprocal of the quotient of a number and 7. So we're multiplying 6 and the reciprocal of the quotient. So the quotient is going to be what kind of problem? A division problem. Well, anytime that it tells you the quotient of and then it tells you in that order, that is how you're dividing. So it's the quotient of a number and 7. So we're dividing a number by 7. So what that should look like is x over 7. But notice it says the reciprocal. What does the reciprocal mean? The reciprocal means we're actually going to flip that problem. So it's going to be 7 over x. So 6 times 7 over x, it's nonlinear because 7 divided by x is rewritten as 7 times x to the power of negative 1, which is a power of x other than 1 or 0. Number 4, twice a number subtracted from 4 times a number added to 15. So we have twice a number and it's being subtracted from 4 times a number added to 15. So if we simplify that, we're going to get 15 plus 2x. And this is going to be linear because, again, we don't see a power greater than 1 or 0. Okay, our last one, the square of the sum of 6 and a number. So the square, so we're squaring. What are we squaring? The sum. What kind of problem? Addition. And what are we adding? 6 and a number. And that would simplify once we we can either write that as 2 expressions of x plus 6 and do the FOIL method. Or you can write this out as x plus 6 times x plus 6, however that works for you. But it would simplify to x squared plus 12x plus 36, and that would be nonlinear because this term x squared has a power other than 1 or 0. So again, take some time if you need to pause the video at any moment and compare our answers next to the guided practice problems. If you got one incorrect, try to figure out what exactly you did incorrectly. All right. So now that we've done this independent practice, let's recap a little bit on what we have talked about today and kind of summarize our lesson. We have definitions for linear and nonlinear expressions. We know how to use the definitions to identify expressions as linear or nonlinear. We can write expressions that are linear and nonlinear. A linear expression is an expression that is equivalent to the sum or difference of one or more expressions, where each expression is either a number, a variable, or a product of a number and a variable. A linear expression in x can be represented by terms whose variable x is raised to a power of 0 or 1. For example, 4 plus 3x, 7x plus x minus 15, and 1/2 x plus 7 minus 2 are all linear expressions in x. A nonlinear expression in x has terms where x is raised to a power that is not 0 or 1. For example, 2x squared minus 9, or negative 6x raised to the third power plus 8 minus x. And 1 over x plus 8 are all nonlinear expressions in x. Let's complete our exit ticket for today. So here's our exit ticket. Feel free to pause the video and write down the expressions however you feel that you want to do this. So we have 7 subtracted from 5 times a number, and then the difference added to 9 times the number. So I first want you to write that expression, and then again tell me if that's linear or nonlinear. Next one, 3 times a number subtracted from the product of 15 and the reciprocal of a number. So think about what we did earlier when we saw this term reciprocal. Take a moment and see if you can first write these expressions down and then tell me if they are nonlinear or linear expressions. For the sake of time, I'm about to go ahead and show you the answers, but remember, if at any point I'm going too fast, please feel free to pause your video. So here are our answers from today's exit ticket. So for number 1, we're gonna let x be a number. So I have 7 minus 5x, and then it's gonna be added to 9x. And that is going to be linear because we don't see a power greater than 1. Or 0. For number 2, we get 3x minus 15 times 1 over x, and again it's going to be nonlinear because the reciprocal of a number, 1 over x, can be rewritten as x to the negative first power, and that's going to be an exponent different than 1 or 0. I enjoyed doing some mathematics with you today. Thank you for inviting me into your home. I look forward to seeing you in our next Tennessee's At Home Learning Series. Bye for now.